All right, let's quickly talk about heat transfer. You've probably talked about these three methods of heat transfer probably from the time you were in the 4th grade all the way on up, and we need to rehash them again. Let's go ahead and just say that these are methods of not necessarily heat transfer, but just energy in general. All right, energy, especially in the form of heat, can be transferred by these three methods. All right, this is mainly heat transfer. Remember, heat is just energy. So let's just think about this as energy transfer. So energy can be transferred, first of all, by convection, also by conduction, and by radiation. Convection, if you don't remember, is heat transfer by bulk flow of a fluid. Bulk flow of a fluid or liquid. This could be a liquid or a gas. Liquid or a gas. Bulk flow, in other words, a fluid in this sense is anything that will flow. Convection is heat transfer by bulk flow of fluid. This is actually the most efficient heat transfer. The most efficient heat transfer method there is, because you're not really influencing the molecules in another substance to change. You're literally taking molecules of one substance and you're moving them to another place where you want the heat to be. That's efficient. You take as much heat as possible and you move it to another place. Some examples of convection are the heater in a room. I'm sorry, I can't write when I'm filming videos. Heater in a room. Somebody texted me. When you have a heater set up in a room, let's imagine that this is your house. What happens is, if that heater is over here on one side of the house, we all know that hot air rises. That is the main component of convection. When hot air rises, it displaces the colder air that's at the top of the house, and that colder air begins to come down to the bottom, and the whole thing sets up this circulation, this convection current, and the air circulates around the house like this. That's a convection. That's heat transfer by convection. Also, wind transfers heat. Whenever you have a cold front or a warm front, that's convective heat transfer. That's taking warm air, heat energy, and literally moving it to another place. Also, another really important fluid that transfers convection that's very important to you personally is your blood. Your body transfers heat from its inside to the inner core to the outer extremities because of convection. You look at your fingers, there is a little bit of heat produced in your fingers, but not near as much heat as can actually keep up the temperature in your fingers. The reason why your temperatures are the same temperature as your internal body is because heat is transferred from your inside to your extremities by convection, by the bulk flow of a fluid, and that fluid is your blood. You can think of a hair dryer, ladies. If you have a hair dryer, that is heat transfer by convection, the bulk flow of warm air. There's lots and lots of different examples of convection. These are just 4 that we think of commonly. Conduction. Conduction is the easiest to think of. It's the heat transfer by direct contact, right? This is the one that we all think of when I say, what's an example of conduction? Well, everybody thinks about, well, don't go touch the stove. Right? You stick your hand on the stove, you're going to feel it's hot because heat gets transferred to your hand by conduction. Literally, the molecules that are moving in that hot object, because you're in direct contact, they are going to influence very quickly the molecules in your hand to move quickly. That's heat transfer by conduction. So touching a stove, let's also think more humanistically. Let's talk about a pan on the stove. How about that? When you cook food, heat is transferred to the pan itself by conduction. Now, within the pan, you have water, and you get convection currents set up in the water, kind of like in this house, because the water is a fluid. Also, if you've roasted marshmallows before, if you leave the coat hanger in the fire too long, the end gets hot. So I'll say end of coat hanger gets hot when roasting mallows. Right, the end gets hot because of conduction. You have the end of the coat hanger that's actually, here's a fire. You have the end of the coat hanger that's actually in the fire. That gets warm by conduction and really convection mostly. But your hand is on this end out of the fire. The reason why your hand will end up getting hot is because heat begins to move up the coat hanger by conduction, because the molecules of the coat hanger are in contact with themselves, and that's why you feel the heat there. You can also think about if you came into my classroom or another room. A lot of people complain about my room being cold. You sit down on a chair, so sitting on a cold chair. You sit on a cold chair, and it's cold at first, but eventually you start to warm up the chair because of your own body heat. And the last method of heat transfer is radiation. That's heat transfer by electromagnetic radiation. Heat transfer by electromagnetic radiation. Lots of different examples of radiation. One of the most misunderstood and probably the most important method of heat transfer, the most overlooked for sure. The most important example of heat transfer by radiation is our sun. Every single amount of energy that we have on this earth eventually got here through radiative heat transfer from the sun. If we didn't have radiation, we would have no energy on this earth. From this radiative heat transfer, we can have conductive and convective heat transfer between different objects, but radiative heat transfer from the sun is what starts it all. If you're sitting next to a fire, you feel its warmth because of infrared radiation, the heat that is radiating from that fire. If you have a lot of people in a room, it will begin to get warm because of the body heat of those individuals. Body heat in a room starts to get warm because of the radiation that comes off of the body heat, becomes off of the bodies of each of those people in the room. It starts to heat up the air. That's radiative heat transfer, and that can also set up a convective current as well. Also, your microwave. Your microwave is an example of radiative heat transfer. It's a little bit different because the microwaves actually transfer, they don't transfer heat energy directly. What they do is they influence the molecules of your food to move more rapidly and thus heat up, but still it's radiative energy transfer. Remember, we're talking about energy transfer in general. And so in that sense, because we're going to consider electromagnetic radiation later on, there's really no difference from one end of that electromagnetic spectrum to the other, so we can still consider that a microwave is radiative heat transfer. So those are your methods of heat transfer. You need to know what they are, how to define them, and be able to give me some examples of them.